Hello, let's continue our Sudoku adventure with Spin by Palfly Kampling. So the constraints today are killer cages and modular lines, not entropic lines, modular. Modular are groupings of 1, 4, 2, 5, and 3, 6. So just wanted to point that out. Also, I will go over the rules carefully now for those who don't know how these work. So we do have standard 6 by 6 Sudoku rules, meaning in every row, every column, and every 2 by 3 box, we are placing the digits 1 to 6 exactly once each. We also have these cells surrounded by dotted lines. We call those cages. The dotted lines are cages. And specifically, we have killer cages. And so the killer part means that we're dealing with sums. It's kind of an old name. It was one of the very first variants invented for Sudoku. And so they called it killer because killer was harder. I don't know that that's really the case, but the name stuck. Anyway, they really should be called sum cages or something. But anyway, it means that the digits in the cage sum to the value in the top left. So for example, we could have 1 and 4 in here. 1 plus 4 is 5. That would fulfill this cage. But there's other ways to fulfill it. You can't just guess. In addition to that, we do, and so these add to 7, these add to 6, etc. In addition, we do have modular lines. Now, because these are 3-length lines, I'm going to simplify the rules for this puzzle. If we did have any lines longer than 3, I'd have to explain it a bit more deeply. But really, the way these modular lines in particular work is we're going to have one of each of a group. We're going to have one of each of 1, 4, 2, 5, and 3, 6. So we need to make sure each of those groups is represented. These groups are the different mod 3 groups. So if we were to divide 3, 6 by 3, we'd get 0 as a remainder. 1, 4 divided by 3 gives you 1 as a remainder, and 2, 5 divided by 3 gives you 2 as a remainder. And so these are the groups mod 3. And so there's 3 of those groups, 1, 4, 2, 5, 3, 6. We're going to have one of each on the line. The order doesn't matter. We could rearrange them. But what we can't do is put like 1 here and 4 here, because these are both from the same group. We need one of each group. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. I think there's some low-hanging fruit with these restricted cages, because 5 cages can only be 1 plus 4 or 2 plus 3. 6 cages can only be 1 plus 5 or 2 plus 4. So what's interesting about 5 cages is they can't have 5 or 6 in them, and 6 cages can't have 3 or 6 in them. 3 or 6 is interesting because that is one of our modular groups. So we're going to need a 3 or 6 in this on this modular line here, and this ends up being the 3, 6 because it can't be in the 6 cage. We can't do 3 plus 3, that repeats the 3, and 6 plus 0, there's no 0. So if this were a 3, that we need to add to 7, right? So if this were a 3, this would be 4. If this were a 6, this would be 1. 1, 4 is also a modular group. And so this can't be 1, 4, making this a 2, 3 pair. Nice. Okay, so here, this is something that happens a lot when you have cages that are 1 apart from each other. And particularly in 6 by 6, they're interesting when 6 by 6 has roping. And I think I haven't explained that in a bit. But in 6 by 6, you always get horizontal roping. You sometimes get roping in 9 by 9, not always. But in 6 by 6, you always do. Let's call whatever these digits are, let's call that green. And let's call whatever these digits are purple. So I've sort of split the digits in half. We have the green digits and the purple digits, 3 of each. Well, what are these 3 digits? Well, they can't be any of the greens because we don't have any more greens for the row. So these 3 digits are purple. And what are these 3 digits? Well, these are the green digits. So you can kind of split the digits in half, and whatever digits go here end up here. It almost seems obvious, but we can think about that generically now. We can say, well, we know 2 of our 3 digits that are green are 2 and 3. 2 and 3 are 2 of our 3 green digits. We don't know what the third one is, but that means that 2 of these digits are also 2 and 3. Well, the 3 needs to go somewhere, and they aren't in this 6 cage. So this ends up 3. Which makes this 6, which makes this 1. Nice. And that makes this not 1, which means this is not 5. This and this 1 means that's not 1. This 3 means that's not 3. So no 1 means no 4. No 3 means no 2. All right. Nice. But also we need a 2 in green, which is going to end up in the 6 cage now. So if there's a 2 in the 6 cage, there's also a 4. So that ends up being a 2, 4 pair. And now we know what the third green is. It's a 4. So that's a 4. Resolving this as 3, 2. Very nice. So roping really helped us think about this nice and cleanly. And so now we know what the purple digits are. They are the other digits, 1, 5, 6. This can't be 1, this can't be 6. Okay. So we can clear out these colors now, but I just wanted to use that to demonstrate the roping. Now there's a 1 on here, which means there can't be another 1 on it. So this ends up 5, 6. That places the 1 here. This can't be 1, which means this is not 5, leaving a 2, 4 pair, which resolves this 3, 2. 3 in the corner, we get a do. This 2 tells us this cannot be 5 because 5 is in the same group. So that's 6, that's 5. Nice. All right, well, that's a lot of digits. Let's do some low-hanging fruit here. We have a pair in this column. We need a 5, 6. We can resolve it, 5 and 6. These add to 7. 2 and 6 are gone. So this is only going to be, it's not going to be 1, 6, right? It's not going to be 2, 5. It's only going to be 3, 4. That 3, 4 pair does resolve this as 2 and 4. That means this is a pair as well. We need a 1. The 1 cannot go on the modular line with the 4, so the 1 goes here, and we need a 5. Well, now there's a 4 and a 5 on here. We need a 3, 6. That goes here. This has to be 6 because the 3 is in the 7 cage. Also in the column. And then this is a 2. Nice. Okay, well, that was... that resolved a lot. Almost done with the puzzle, I think. How should we approach the rest of this? How about this pair? We need a 4 and a 5. Okay. Here we need 1, 3, 6, just referencing our roping. The 3, 6 tells us this is the 1. Okay, so this is a 3, 6. I guess that doesn't matter. Anyway, this 1 looks up, giving us 5. And then now we get this digit just for free. That's a 4, giving us 3 and 4. This 4 tells us this can't be 4, because it needs to be a different group. So that's 5 and 4. It gives us 2 and 4 here. All right, I think we can just finish off. This is 2, which goes here, and 3. It gives us 6 and 3, giving us 1 and 6. We need 1 and 5, and we're done. Nice. So the key definitely was thinking about the roping here, thinking about how this 2, 3, I mean, first of all, thinking about how this needed to be 3, 6 was important, which actually came back around and resolved this as a 2, 3. But then now this 2, 3, we need to think about how the 2, 3 ended up down here with this 6 cage. This is always interesting. If you have 2 cages that differ by 1 that are in the same band, right, in the same rope, right, you know there's going to be 1 shared digit and 1 non-shared digit, which is interesting. So cool. Well, that was a neat puzzle. Thanks, Palfly. I hope you enjoyed it. If you did, then why not leave a like, subscribe, and a kind comment below.